Okay, where are we? We've seen that there are potential disadvantages with regard to storing natural gas that was delivered by any other means. If a pipeline was installed in the future, the bulk of any gas storage equipment, spears or bullets, would become obsolete. This is another thing. If you bring natural gas on in this method that I've just shown, and you decide to build a big gas network infrastructure, technically it would become obsolete, depending on how much you wanted to integrate it into your gas distribution pipework for the DEFA planning for the island. So this is another study that could be that should be actually be getting looked at. The other, what I've gone back to is I've revisited the possibility of building a regasification facility. One of the questions we get asked is how much of the we got asked before is how much of the regasification facility could be incorporated into an LNG or a liquefaction facility. Primarily, all you could really say, all you'll keep from it is you'll keep whatever the infrastructure is for the loading and the LNG storage tanks. But then take into account that these two are around about 70 to 75% of the total cost of this entire development. I got a quote on these tanks this morning, and I've been told if they were being built not to Shell's specifications, but to meet the international requirements for storage of LNG, these cost between $650 and $750 per cubic metre stored. So for the size that we'd need on a Cyprus, I've got these coming out at around about up to $270 million. So the total regasification facility shouldn't cost more than $500 million, $500 million. And you've still, as I've said, the tanks, what I've done is I've looked at it as the tanks being of use at a later date if a liquefaction plant was built. Oh yeah, I'll say here, I've received an email this morning from one of the world's biggest manufacturers, and these are the prices they've quoted me. $650 to $750 per cubic metre. And I've worked those figures out on what the island's requirements are. To configure the tanks, what I did was I looked at a diameter of 40, a height of 35. If we had 2 tanks like that, we'd need 19 deliveries per year of gas. The 2 tanks here I've shown 70 and 75 don't exist yet. They're not. This one's in the planning, but they don't actually exist yet. The biggest tanks we've got at the moment are somewhere between 199 and 250. But what I've done is I've just simply tried to show the size of the tank. So I've looked at about 190,000 cubic metre tanks that would require, we'd need 2 of them, 5 deliveries a year, and the weeks between deliveries at 11. The ideal tank size for Cyprus would be somewhere around there. And most of the world's LNG carriers, there are some super huge ones around that now carry up to 250,000 cubic metres. But the bulk of the world's LNG fleet are all around this sort of size. So, or 75% of the world's fleet is around about this sort of size. So these would be the sort of size you'd look at building tanks, because you know that you can take a full load from an LNG carrier. And they're the figures that I've got prices on this morning. And to give you some idea, these 2 tanks here at Sakhalin are 190,000 cubic metres. These are exactly the same sort of size that I would say would work for Vasilikos. Right now as storage for LNG with a regasification facility, and in the future. You'd still be left with some equipment, but a regasification facility is primarily vaporizers or heaters. What you do is you have to heat the gas up to bring it back to ambient temperature. And then these are simply regasification facilities. These, where I said we wouldn't necessarily need a full-time or something permanently over the well. This is something that's permanently over a well, but a lot of it these days is all done on what we call umbilicals. This is turret mooring, where the same ship, the FPSO with a turret mount, comes over the well, or liquefies the natural gas at sea, and then sails ashore. Okay, before any decisions can be made, the various options open to the EAC. When I say EAC, I also mean DEFA, because I did a very similar talk for at the request of the EAC a few weeks ago, where they wanted to know what their options were. And I obviously went through all of these with them. But then EAC said to me, we don't even make the decision. We are forced now. We have to buy our gas from DEFA. So technically, it should be DEFA who are making these decisions. So I've putting aside any commercial aspects on gas supply agreements, because at the time when I gave the talk with the EAC, Noble hadn't stated that hadn't confirmed the fines in Block 12. So I broke the various options they had down into 3 categories as fast track 15 to 30 months. 15 being using the accelerate gateway possibility, minimum infrastructure costs, but you could actually get something built, you could get natural gas onto the island somewhere between 15 and 30 months. And then I've looked at the medium term and then the long term option obviously being towards a liquefaction facility. Okay, fast track option 1, natural gas with 1 billion cubic metre handling capability. Gas delivered by pipeline from an LNG FSRUs using turret mooring. This is the one that I'm talking to Accelerate on this, and they said if you had a green light on all of this, they could probably get something done within 2 years. So there is a possibility that if that was the one option that everybody wanted to go for, then it could be done. The disadvantages to it are that the MG would probably need to be recompressed and stored in spheres or bullets, which I've discussed. The only recommendations can be made is that they need to do a high-level concept study, which shouldn't take longer than a month. That really needs to be getting done now. I'm not sure what the team of experts are doing that have been appointed by the government, because everybody that I talk to who supplies major LNG equipment haven't been getting calls from anybody. So I'm like, I don't understand why they're not getting calls. Natural gas facility with gas is another option, is to bring natural gas coming from LNG FSRU with conventional infrastructure. Now this takes a lot more time to build. The disadvantages are exactly the same as option 1. That any long-term facilities you build, you'd have to decide if you needed to incorporate them into the gas transmission network for the island. Again, this is one option, but while doing this one, you would actually be looking at what the costs are for building an onshore facility for deep sea ships. Medium-term option 1. This is a regasification terminal. Now, talking to the manufacturer of the tanks this morning, they said that they could build these tanks at 190,000 metre cube within 4 years. But that would be without, having worked on a lot of these projects over the last couple of years, and the biggest ones in the world, the problem is that we normally have to, the major owners of these pieces of equipment, people like Shell and BP, tend to stipulate their specifications on you. And the specification and signing off process. That takes time. It can take a year just to get sign off on a design. You've also then got to do everything to the way that you're being dictated to by the majors. Now, one way or another, I would assume that one of the majors is going to get involved in this, which means that they are then going to dictate to you what specifications you work to, how you design it. So you're then going to go back to base. And normally, we wouldn't install an LNG tank within 6 or 7 years. But you could do it in 4, and I've had that from the horse's mouth, from the actual manufacturers of these tanks. So it depends on how somebody would want to play it. But that's it. The disadvantages are, is because of the size required, design and planning and construction, these will probably not be ready for commissioning and handover. I've said anything less than 3 years. I'm being extremely conservative. Period of time required to design and plan them, it's just a very long time. And it's major capital costs. You've got to spend $300 million, the best part of $300 million just for 2 tanks. And you're not going to be able to do anything with them for 4 years. Again, I'd recommend they look at this. I really believe that the regasification facility is the best option for Cyprus, because we can use the bulk of the major equipment at a later date. We're literally only writing off about $150,000 worth of equipment, if that. Sorry, well, we're writing off a lot of money, $150 million worth of equipment, but over the period of time, we're going to be without gas here for at least 6 years. The difference in time between building a regasification facility and a liquefaction facility is about 6 years, if we pulled our finger out and started doing something about it now. So for 6 years, we're going to still be running on liquid distillates and paying through the nose for our electricity. I think that's probably why the EAC haven't come here today. Okay, medium-term LNG regasification terminal with marine infrastructure. Again, it's the same thing, regas. Natural gas pipeline from Cyprus fields, probably linked to Israeli fields. Advantages to this is it's a permanent feature. It's expensive. As we've shown with the Gaussy project, we're looking at probably around about the $2 billion mark. And if we really did pull our fingers out, we could probably do it in about 4 years. We'd be pushing our luck to do it any sooner. Then this comes up with sizing questions, including possible future needs. Would you put the pipe in? And you'd only need to bring a pipe here for about 8 to 12 inches, but you would normally lay a pipeline in that deep, that diameter, in that depth of water, with the amount of hassle you've got to go with it, just to bring it on for the domestic market. So you'd probably size it that you can put through more gas through it at a later date, and therefore run an LNG facility off of it. Again, this they need to do. Somebody needs to do high-level feasibility with this now. Okay, an LNG liquefaction plant that can liquefy Cyprus gas, possibly future gas from Israel. Again, this is the liquefaction discussion. But at the moment, where we are is I personally believe that the best strategy we could have would be to build a regasification facility as soon as possible, and design that around as much of the equipment being used at a later date in a liquefaction plant. And that plant could be designed to accept gas, I reckon, within, as I say, 4 to 5 years, if work was started on it immediately. Oh, there's just a quote there from Surrey and Wood. I don't know if any of you have heard of the Wood Group, but the Wood Group started off in the 60s as a fishing company in Aberdeen, fishing in the North Sea. Ian Wood went and studied philosophy, and his dad asked him to come into the business when he wasn't feeling too great. Well, Ian took the business and started supplying the rigs in the North Sea from the 40s right the way through to current day. What started off as a 2-trawler fishing fleet, the Wood Group last year rolled 2.4 billion and has 14,000 employees, and in fact own the company called MSI Kenny, who are doing the modelling for Noble of the subsea pipework, I believe. MSI Kenny? Tommy, yeah, I know the guy who's doing it. Tommy Groller, yeah, anyway. But the Wood Group owns the company that's actually doing the subsea modelling for Noble. And Sir Ian Wood is, his advice to anybody who's looking at moving into the oil and gas business is take a global perspective of it and not a local one. Okay, thank you. Any questions?